I made a clock. It's a 24-hour clock and it runs counterclockwise, which is exactly from east to west like the sun does. It also spots a Holocene calendar, the phases of the moon and how day and night compares to each other at your latitude on this specific date, or any latitude. You can change that. I'll show you how. So it's a bit of an eccentric clock made by a bit of an eccentric man. I'll do a demo now and hopefully you'll see it's actually fun to play with. So when you start the thing, it will ask for your location. I'll put it on allow now for now, and you see it has taken my location. Now if I would have refused, it would be the same number because that's the standard, so there's that. Anyway, depending on where you are, that number will be the same, or well, more or less the same. The farther away you are from me, the more difference we have. Okay, F11 to maximize it, and you can see the clock goes from 0 to 23 and 0 again. The dot you see there is the hour, like an extension of the hour hand actually, or a projection. And you can see the minutes going round counterclockwise, and the clock also going counterclockwise. Now for the colors, you see, of course, yellow is day, and the blue, purple, deep blue is night, midnight. And then we have dawn and dusk in the more orange regions. And then of course we have the moon. Not much moon today, it's only 5%, so yeah, that is it. Now you can change the latitude, and if we do that, you'll see that the amount of night changes if we go up north, and yeah, that's almost completely day. And here we are at the North Pole. We have a permanent day, always light. So yeah, nowadays now this is the equator, and you see day and night are the same, 12 hours day, 12 hours night, and that's always so across the year, so that stays the same. If you go farther south, you can see here we are nearing the South Pole, and at the South Pole now it's the eternal night, so dark all day. So you can reset that, of course, and you can also change the days. This is day 1 of the year 12,024, or 2024 if you like, but it's a Holocene calendar. And you see it's a much shorter day already, so that's how it looked. And then here you can see the equinox, and you'll see the jump for daylight saving time any moment now. There it is. So you can see what that does. The sun doesn't care, of course, it's just the hours that are a bit different. And if you look at the brightest yellow, you see that noon is about noon for the sun, around 1400 hours. And if you go back, you see it's around 1300 hours. So even in winter time, we're still an hour in advance of the sun actually. You can also see the moon changing, huh? The moon phases. And if you see change the latitude again, you see we passed the equator and we still had 12 hours day and 12 hours night here. So that stays the same throughout the year actually. Yeah, the jump you see is again daylight savings time going into effect, or winter time again. But for the rest you can see that the 12-hour night, 12-hour day at the equator stays the same. And we have night at the pole, but when you get closer to December, as you've seen, you have day, like now. That's a full day, no night anymore at the end of the year at the South Pole. And if we go back, there we have the eternal night starting. You can also see the moon change if we go back or forward in time, from full moon to new moon and back. And if you change the latitude, you'll see the orientation of the moon changes too. So at the North Pole it's vertical, right? And so let's change it a bit, yeah, like that. If we go back to the equator, you'll see it tilts and tilt and tilt more until at the equator it just lays down. And then if you go farther south, it'll tilt more and more and more, and then it's actually the mirror image of what you saw earlier. See, it's just the opposite of what you saw at the South Pole, North Pole. So you can find the clock at the GitHub repository. I'll put the links in the description. And here you see the Dutch explanation, but don't worry, if you scroll even further down, there's an English translation for it. So about the Holocene calendar, that was invented or thought up by an Italian physicist in the 1990s. And it's just actually adding 10,000 years to the year we have now. Why? Because, well, 11,700 years ago, more or less, was the end of the Ice Age and the start of the beginning of human civilization as we know it now. So you're living in the year 12,026, or the 12th century of human civilization, actually, according to that calendar. It's a great idea. So it also has a year zero in which our calendar doesn't. I mean, the Romans didn't have a symbol for zero. They didn't like zero all that much. So it's overall a very good idea for this Italian guy. And here you see the Holocene era date in the clock. So this is today's date and the time I recorded that. There's another part to this. This is sun.html, which gives you a lot of data about the sun at this specific latitude and longitude. So you can see sunrise, sunset, dusk, dawn, nautical, civil, and so on and so on. So if we change this to the pole, then you can see that we have polar day, and if we say get minus 90, that's the South Pole, then you can see there is polar night. At 70 degrees we have sunrise and sunset, but no dusk, no dawn. So that's because the sun is barely below the equator, so there's not much dusk and dawn going on. So if you look at that on the clock, you'll see this is the night at 70 degrees north. It's not much of a night, and it's also not very dark. And if you go a bit further, well, then you're in permanent day. So fun to play with. Of course that will change, because if we go to, this is summer solstice, and so if you look at when the night is now, it's about 60 something degrees, and but that's in the future. If we go back to today, you'll see at that latitude they still have some night. So you can check this out. It's there's a lot of things to see and to learn. If I put 50 again, which is about where I am, then you'll see all the values for today. This is another thing. This is moonphase.html. This is educational, shows you the moon and the orientation according to latitude. It's the same kind of process I use in the clock, but here you have the sliders to show it. It's just fun to play with, and slightly educational, I guess. So that's Moonphase HTML, another fun thing to play with. I'll put that link in the description also. It's not totally accurate. It's it's simplified, but it's accurate enough to show the phenomenon, and it's accurate enough for the clock, certainly. So the calculations about the day-night, these are very accurate. The calculations for the moon, they are accurate, but the representation of the moon is not 100% accurate, but fair enough and close enough, certainly, for an app like this. And you can see, if you slide through the days, that the moon changes. And from new moon to another new moon is more or less a month. It's slightly less, but you can see the animation neatly. As I said, fun to play with. So that's my eccentric clock in a nutshell. As I said, I'll put the URLs in the description. Have fun with it.